This is Unit 2, the solving unit. We're going to start with solving with integers, which is in Chapter 2 of your textbook. So this is Chapter 2, Section 1, about just introducing variables. So there's some vocabulary terms we're going to hear a lot of throughout the rest of the course, and one of them is expression. An expression is any collection of variables and constants, and we'll talk about what variables are and what constants are in just a minute. The thing about an expression, there is no equal sign. No equal sign on an expression. An equation is two expressions set equal to each other. So we'll have an expression on one side, an equal sign, and an expression on the other side. So an equation, you can kind of see it in the word, equation has an equal sign, expression does not. A variable is just an unknown value. An unknown value is a variable. Unknown values are represented with a letter. We use a letter when we don't know what the number is supposed to be. Generally, we use the letter X. It can be any letter, but we generally use the letter X to represent a variable. And then a constant is a known value. So variables are unknown, constants are known values. So a known value, which can be any number. So we're going to have variables with letters and constants, just numbers, put together with adding, subtracting, multiplying, all kinds of different ways to create expressions. And then if we take two expressions and set them equal to each other, we have what we call an equation. So you're going to hear these four words a lot throughout the solving unit. So a lot of students want to know, why do we use variables? Why are there letters in math? So we're going to go through a couple scenarios to help just clear up why we have to use variables sometimes. So the scenario that the textbook uses talks about the bookstore. It says the bookstore is told to order the class limit of textbooks and 5 extra for each course. Each course has a different class limit. So we create an expression to represent the situation. So class limits can vary. There can be all different kinds of class limits. And we all know that there's 5 extra for each class limit. So this expression to represent the situation, we decide to use the letter C to represent the class limit. So the expression would be C plus 5. That's the class limit plus 5 extra books. C is our variable. To vary means it's going to change around based on the class limit. Plus 5 is our constant. So we have our variable and our constant. So the same idea works for your gas bill, your water bill, your electric bill, your cell phone bills usually work the same way. You have a variable at a certain rate. So your gas bill is charged at a certain rate per cubic foot, I think it is. Water bill the same way, electric bill, sometimes cell phone bills per minute, per text message, per data value, or data amount. Cell phone bills generally work the same way. You have that variable at a certain rate and a constant that you pay each month. So the constant would be like a monthly fee. So you have your variable at a certain rate per unit and a certain fee you pay each month. If you ever look at one of these bills, you'll see that. But let's get back to the textbook scenario. Using the textbook scenario, how many textbooks should be ordered for a math class with a class limit of 24? So we're going to use our expression C plus 5 to help us with this. The class limit's 24, so that would be 24 plus 5, which is 29. And then how many textbooks should be ordered for a biology class with a class limit of 18? 18 plus 5 gives us 23. And finally, how many textbooks should be ordered for an English class with a class limit of 30? 30 plus 5, 35. So it's the same expression, C plus 5, and we're plugging in different values for C, but we're adding 5 each time. So this is the variable, because it's always different, and then the constant is always the same. So here's an extension to this scenario. Recently, textbooks have become digital, like our textbooks digital, and there are other places to buy textbooks other than the bookstore. So some students go to Amazon or different places to buy the book. So they changed the rule for ordering textbooks. The rule now is 10 less than the class limit. So instead of the class limit plus 5 extra, now we're ordering 10 less than the class limit. Question is, which expression should we use? 10 minus C, so 10 minus the class limit, or the class limit minus 10? Take a minute and think about that. Does it really matter? Are these different? If you need help, think about the class limits we had before, 24, 18, and 30. Would it make sense to do 10 minus 24? Or would it make more sense to do 24 minus 10? Take a minute and think about that. And hopefully you've decided that C minus 10 is the correct expression. When something is less than, when you see that phrase less than, that's an indication that the thing that comes after that has to go first, and then the number. So C minus 10 is our new rule. We'll practice more of that when we get to chapter 3. So using the new rule, how many textbooks should be ordered for math with a class limit of 24? Well, now it's going to be 24 minus 10, so they're only going to order, not 24, 14 books. Biology with a class limit of 18, well, they're going to take off 10, and they're only going to order 8 books. English with a class limit of 30, take off 10, and now they're only going to order 20. So again, the variable will change based on the scenario, and then the constant will stay the same. So C minus 10. Just another expression, and this is called evaluating. So doing this, it's called evaluating the expression. So we'll practice that a little bit more. Alright, so a new scenario. It says, from all the flooding this year, Wimberley residents are having to put up a lot of new fencing. And I was in Wimberley in August, and this is very true. What expression can be used to calculate the amount of fencing needed to enclose any square area? So the key word there is square area. And if it helps to draw a picture, I like to draw a picture. So square area, we know that a square is the same on all 4 sides. So if we label one of those sides X, and we're trying to put up fencing, fencing goes around the edges of the square. So if X is one side, we need 1, 2, 3, 4. 4X would give us what we call the perimeter for the fencing. 4 times X, if X represents one side of that square. So how much fencing is needed at the length of one side is 7. We would do 4 times 7 and figure out that we would need 28 feet of fencing. If each side is 10 feet, we would need 4 times 10, which would be 40 feet of fencing. And if each side was 4 feet, 4 times 4 gives us 16 feet of fencing. Anytime an expression has a number being multiplied, which is what we were just doing, multiplied by a variable, that number is called a coefficient. You might have heard that before, coefficient. It's different than a constant. So if an expression has a number being multiplied, so if they're right next to each other, we know that that indicates multiplication. So it's not 4 plus x, it's 4 times x. We did 4 times 7, 4 times 10, 4 times 4. So this was all multiplication. So this 4 is called a coefficient. So let's look at some examples. These are all expressions. We want to identify the variable, identify the constant, and now we want to also identify the coefficient. 3 things to identify: the variable, the constant, and the coefficient. We look at this first expression. The 3 is our coefficient. I'm just going to write COEF for coefficient. X is our variable. And the plus 5 is all by itself. That is our constant. So there's some homework questions that want you to identify the coefficient, which would be just the 3, the variable, which is the letter, and the constant, which is the number all by itself. On the second example, the 7 is our constant because it's all by itself. The 2, which we think of as negative 2, is our coefficient. I'm just going to put COEF. And then the x is our variable. So we're just identifying pieces of the expression. Here we have 4, that is our constant because it's all by itself. This little negative x is technically a 1. Negative 1 is our coefficient, so negative 1. And then again, x all by itself is our variable. And then one more time, this negative is really a negative 1. That is our coefficient. The x all by itself is our variable. And the plus 2 is our constant. So just get very comfortable with what numbers are doing what. The 3 is being multiplied with the x. That's a coefficient times a variable. The constant is by itself. You'll hear me using these 3 words a lot. Coefficient, variable, and constant are words we're going to see a lot. All right, now let's practice some more evaluating expressions. So our expression is 2x plus 3. I'm going to write it a little bit bigger over here. 2x plus 3. That's 2 times x plus 3. And it gives you different values for x. So evaluate the expression 2x plus 3 when x equals 7. So that means instead of putting an x in the equation, I'm going to do 2 times 7 plus 3. We know that 2 times 7 is 14. And then when we add 3, that should give us 17. So we're going to get actual answers for this by plugging in whatever the number is where we see x in the equation. In the expression. So we have 2 times negative 5 plus 3. 2 times negative 5 is negative 10 plus 3 should give us negative 7. When x equals 10, that would be 2 times 10 plus 3. So 2 times 10 is 20, plus 3 is 23. And finally, when x is 0, that would be 2 times 0 plus 3. 2 times 0 is 0, 0 plus 3 is 3. So you'll have several on your homework where you're just evaluating. Evaluate is the word. Evaluate the expression, which means you take whatever the expression is and plug in various values for x. So that's why it's called the variable, because it changes. Notice the 2 stays and the 3 stays. The coefficient and the constant are staying. The variable is changing. And finally, for this section, well, sometimes in this section they give you a chart, and it kind of looks confusing. They're giving you a value for x and a value for y, and they're asking you to do different things to the values. So the first one says x plus y. So that's 2 plus negative 3, which is negative 1. The next one says x minus y. That's 2 minus negative 3, which we can do keep, change, and that gives us positive 5. And finally, x times y, xy, would be 2 times negative 3, which is negative 6. If you'd like to, you can pause the video and try to fill in the rest of the chart using new numbers each row and filling in all 3 operations or all 3 expressions with the new numbers. This would be negative 6 plus 5, which is negative 1. Negative 6 minus 5, which you can do keep, change, change. Change, change, that would be negative 11. And you can also, let's see, negative 6 times 5 is negative 30. And then the next one, 0 plus 7 is 7. 0 minus 7 is negative 7. You can do keep, change, change. And then 0 times 7 is 0. The last one, 8 plus negative 1 would be 7. 8 minus negative 1, careful here, we're going to do keep, change, change, that should be positive 9. And then 8 times negative 1 equals negative 8. Notice when it comes to the multiplication, I'm throwing parentheses up around the value. So I'm putting parentheses around y. That is so that I don't misread what I'm trying to write. So it's a very good idea anytime you've got multiplication to put parentheses around your number so that you don't misread what you've written. Alright, and I think there's some more evaluating. It gets a little bit trickier, but it's the same idea, just plugging in values. So these are a little bit more advanced, but we're still doing the same thing. So it says evaluate the following expressions given x equals negative 3, y equals 5, and z equals negative 1. We still do not have our calculator, so make sure that you're not using your phone as a calculator at home. So z to the 5th would be negative 1 times negative 1 times negative 1 5 times. This would work out to positive 1. And then that answer with that one would be negative 1. And then those two would make a positive 1 and just keep switching. And you should end up with a negative 1 when you're done. The next one is x squared y. So x is negative 3. Negative 3 squared. Notice again I'm putting those parentheses up to protect what I'm working on so I don't mess up. Negative 3 squared times y, which is 5. Negative 3 times negative 3 is positive 9. Positive 9 times 5 is 45. So you have to work these carefully, but they're not too bad. The next one is 7x squared, so it's 7 times x is negative 3 squared. Remember order of operations? We do the squared term first. Negative 3 squared is 9, so it's going to be 7 times 9, which is 63. Then we have negative 4 times y, which is 5, times z squared. Remember, we do the squared term first, exponents first, if you need to write your order of operations. So you don't forget, exponents first. Negative 1 times negative 1 is positive 1. So it's negative 4 times 5 times positive 1. And we work left to right. Negative 4 times 5 is negative 20 times positive 1 is still negative 20. So take your time, one step at a time, and follow the order of operations. A couple more. These are a little trickier. Again, same idea. We have x, y, and z at different values, and we have some expressions that we're going to evaluate. Remember, these vertical bars are your absolute value bars. So they kind of work like parentheses. We're going to do the absolute value of x, which is 4, times y, which is negative 2. Well, 4 times negative 2 is negative 8. I'm going to leave that there for a minute. Then it says plus y, which is negative 2, plus 2 times z, which is negative 6. We're going to do the multiplication first, following the order of operations. So that's going to be negative 2, and then positive 2 times negative 6 is negative 12. Oops. Straight bars here. And then keep, change. You should, I don't want to overlap here. I'm going to come up here so I don't run out of room. You should have the absolute value of negative 8 plus the absolute value, negative 2 plus negative 12 is negative 14. Now remember, absolute value always becomes positive. It's asking how far away is negative 8 from 0, so it's just 8. And how far away is negative 14 from 0? It's just 14. 8 plus 14 is 22. So one step at a time. These can get very overwhelming. You just work one step at a time. Generally, I work all the way down, but I don't want to run into this problem. All right, the last one here for this section. We're just going to work the top. We have z squared, which is negative 6 squared over negative 3 times y, which is negative 2, plus z. So it's plus negative 6. Negative 6 squared is 36. The bottom, negative 3 times negative 2 is positive 6 plus negative 6. Positive 6 plus negative 6 is 0. When 0 is on the bottom, we have what we call undefined. Remember, when it's a number over 0, it spells no, and it's undefined. So just work out one thing at a time. I just worked out the top, and then I slowly worked out the bottom to make sure I didn't mess anything up. So that's section 2.1, just kind of getting familiar with using letters. And most of the time for this section, they'll give you a value for the letter, and you just plug it in where you see that letter into the expression, and you work through it one step at a time. I'm going to pause there, and then we'll start in section 2.2.